Thanks very much, and I'd like to just thank the organizers for inviting me, and I'm going to be using a pointer a little bit, so I apologize to those looking at that screen over there if they can't see what I'm trying to highlight. I have no conflicts of interest to declare. These are the bare facts that we're all aware of, and Tobacco Atlas gets published renewed every 2-3 or so years. It'll be interesting to see how this changes in the next couple of decades when they get to the 20th edition. And I'm going to focus on the third of the 6.5 million deaths that are attributable to cancer. I'm not a cancer specialist or even a toxicologist. I come from the environmental sciences, where we use the results of toxicology and so on to protect people from environmental toxicants. And I've applied some of those techniques to tobacco. Of course, what we have now is the disruptive technologies, and it will be interesting to see how, if things accelerate, as we've just heard alluded to. I will talk about nicotine delivery by aerosol only, not any of the other forms of delivery. I'll focus on cancer, and I want to try and get to a point where we can start to address quantitatively questions like, do different forms of nicotine delivery have less, possibly even more, carcinogenic potential than smoking cigarettes? So everything will relate back to cigarette smoke. To start with the sources or the culprits, however you want to look at it, tobacco leaf is where many of the toxicants and carcinogens and so on start, although not all of them by any means, or purified version that may be used to make up juices or put in pharmaceutical products or whatever. As an environmental scientist, we always have this kind of, we worked with this kind of strategy starting from source, or to try and understand the pathway, basically. We call it from source to sink. You read old papers in the tobacco literature that talk from seed to smoke, which I prefer to think of as from seedbed to sickbed. But anyway, that's a personal view on it. We start off with a source, obviously. The point of combustion, or however else you liberate the toxicants, is very important. The temperatures and the way you do it, either self-combustion or heating with charcoal, as with the Shisha pipe, or electronically heating. We get different temperature regimes, and the toxicants that come out can be distinctively different. It's important to bear in mind that the process determines that the input, and the process determines the output. It's mobilized into an aerosol that superficially looks extremely similar. Sorry if I have my back to you people over there, but it looks superficially similar, but there are very significant differences, as we know. And then finds its way into the body through the inhalation route, and we're concerned, obviously, about the fate, but initially there are 3 ways in my schema here. Obviously, the combustion route, cigarettes, roll your own, Cradex, biddies, pipes, etc. Heat not burn, of which the water pipe would probably be regarded as an early version of this. We have much more high-tech versions now that don't use the water and so on, but nevertheless, it's essentially the same concept. And again, the sort of e-cigarette route, where you're atomizing by using a liquid, wicking it up in a coil, heating it up, and creating this aerosol. Okay. But they end up in the same route, and the toxicants, they either get circulated, absorbed, circulated, and either get detoxified and maybe excreted, or they end up having a toxic response as the fate. And of course, as we heard yesterday, we can't really hang around to wait for people to count up all the deaths and so on before we can say things definitively. But we are already beginning to see 5-year. We last at the Global Forum on e-cigarettes, we heard early results of 5-year clinical studies on e-cigarettes indicating very little negative effects. So we're beginning to get these sort of definitive data, but really we're in a bit of a hurry. We've got to come up with the best we can in terms of advice. So biomarkers in the body that indicate exposure or even harm are really very important. But I'm going to focus, and there's lots of toxicology that's outside the body going on, but I'm going to focus on the emissions that really try and intercept these toxicants and carcinogens before they get to the body and work on that. In fact, you really must look at all of these. You can't just take a single one and get a definitive answer. Okay, and the way we do this, of course, is we replicate in the lab these processes, and then we capture it we take the human out of it, and we capture it in a machine, and we send it off to the lab and do some analysis, and no humans are harmed in the experiments. So using standard protocols that we hope, after years and years of argument, more or less replicate human smoking and vaping and so on, but that's questionable at the moment. We try to achieve as much as we can of the FDA list, which we've heard about in previous talks. Very few labs can achieve this. Actually, some people are trying to do rather more, because this is a tobacco list, and we need to add to it toxicants we can expect from e-cigarettes, so the list can be half as big again. I'm going to focus on as many as we can of these carcinogens, some of which are more important than others. Cigarettes have been analysed for donkey's years. We got fantastic data now with lots of quality assurance, and we don't really question the data. It's a bit different from many of the other products, particularly if they're not tobacco products. They don't have reference standards, so quality assurance is poor, and no two labs do it quite the same way. So it's a bit of a pig's breakfast, actually. I'm going to be using a very simple toxicological parameter called unit risk, which will hopefully soon be replaced by something that takes into account more of the dose-response curve. But for the moment, this is what people... For instance, if you're building a power station, cold combusting power station with a big smokestack, and you happen to live a couple of miles away and a kid goes to local school, they're going to get 7 years, 10 years or whatever of exposure to similar sorts of pollutants. The authorities will model it using a simple parameter called unit risk. And I'll use that same risk term, which we will weight by the concentration, the amounts present in the emission, and simply use a very simple additive model where the unit risk and the concentration, the product of the two, are summed for all the carcinogens, assuming the mixture is just the sum of the parts without any synergistic interactions and so on. This book contains 10,000 chemicals identified in tobacco smoke. We've looked, and others have looked at whether the most important of them have known synergistic reactions, or we don't know of any. But of course, that's not the whole story. Exposure, the amount of exposure, you can have a hazard, but it's only risk if you're really exposed to that hazard. So we have to estimate exposure. That's very difficult to do in any defensible way. I'm going to take two proxies. One is the amount of nicotine. After all, that's the purpose of smoking and vaping and so on. So the amount you take in, let's take that as one estimate of exposure to compare different sorts of products. Another is topographic studies come up with, they count how many puffs you will take, what the volume of the puff is, how many you take in a day, and so on. So you can get an estimate of the volume of different forms of nicotine exposure per day, let's say. So I'm using that as a second proxy. Okay, so we want to be able to answer those sorts of questions, and so I'm going to do it simply by making an estimate of the cancer risk using the methodology I just talked about. I've written it up. It's in Tobacco Control at the beginning of the year, and in all cases, because of lots of limitations, some of them can sort of be cancelled out by taking a ratio of like things, a ratio to cigarette smoke. Okay, so everything will be about this ratio. And there's plenty of data. Cigarette smoke is very well characterized. Excuse me if I skip along fairly quickly. I'm fairly keen for my coffee as well. the next 3 or 4 diagrams will be of this type. I should talk you through it very quickly. It's a logarithmic axis, and we don't normally think in terms of log axes, but this is a 10 to the naught. If you remember your high school maths, it is 1. So cigarette smoke ratio to itself is going to be 1. That's 1/10th, 100th, 1,000th, all the way down to 1/1,000,000th, and that's fresh air. Okay, so a medicinal nicotine inhaler comes out at about 1/10,000th of the cancer risk, or the cancer potency, sorry, not risk, which is just comparing the equal volumes, if you like, the potency of the aerosol. So really, we would expect to occupy the space somewhere between cigarette smoke, possibly above, maybe not. We'll see in a moment. Somewhere in here. Every dot is, what I've done is, in the remaining diagrams anyway, each dot will be a single analysis in the peer-reviewed literature, and I've taken all I can find. I've made no judgment about their quality, and there are questions about quality that should be addressed, and we'll see that right at the end. And I've just thrown them in there and plotted them. Okay, starting with combustible tobaccos, I've looked at some alternatives to the usual manufactured cigarette. And by the way, I'll show in green the field for air, where the medicinal inhaler lies, and where tobacco lies as fields. I won't keep it in the data points up to confuse things. As we see, Kretiks, which are clove cigarettes widely used in Indonesia and that part of Asia, sort of fit quite well, and roll your own, which is often thought, the urban myths about being a bit safer. If we compare in terms of the nicotine exposure, they look to be slightly less in terms of the potency, but once you compare the volumes, they fall bang in the field of cigarette smoke. I'm not looking at pipes or cigars because they're really only human exposure. Well, the human absorption is really just in the upper airways, whereas most cigarettes and all the other things we're talking about are taken down deep into the lungs. So we would not be comparing like with like. The new heating device products, the manufacturers published a lot of data on their prototypes. They tried out different blends and so on. And so I've taken all this data from these manufacturers and thrown them in there, and they basically form relatively coherent fields between about 1% between 10% and 1% of tobacco smoke. Some of them have lower nicotine outputs, so consequently, on the equal nicotine plots, then they're dragged a bit of the way towards cigarette smoke, but still generally around between 10 and 1% in terms of potency. So I'll put a shaded area on for those. Okay, the other form of heat not burn, where we have the Shisha pipe, or whatever you want to call it, where it's heated by charcoal, a bit of tobacco underneath. Actually, they do burn a little bit, apparently, but it's mostly heating. And, of course, there are lots of myths, I guess, out there that by passing it through water, it's going to be a lot cleaner, things will be dissolved out and so on. The data, there's quite a bit of data out there, but it's all over the place in terms of one study will look at some compounds, another study will look at other compounds, and so it's not in the right format really for working up as I've done for the other products. Shihade has published a review in which he took all these data and picked out various stats, including the maximum value. So I've just plucked out his maximum value, taken that as a worst-case scenario for these Shisha pipes. And yeah, it falls on heat not burn, as you might expect, but actually the amount of nicotine that you inhale is really very low per puff. And so if you're really trying to get the equivalent amount of nicotine as you might get if you're smoking in a day, it really shifts way over here. On the other hand, they tend not to take observations of the amount of volume taken in a day would place the worst case scenario here. So we really don't know this very well, but there is a case for studying this a lot better. Coming to e-cigarettes, it's a very different story. You can get anything from fresh air, if you like, all the way to even beyond cigarette smoke. Now, like I said, the data are all over the place, different analyses. They've been challenged. Some people, our friend Professor Farsalinos has been bold and challenged some of the analytical, and repeated them actually, and shown them not to be valid, particularly at the top end here. And we should look at that because this is what we need to worry about. But, you know, it's a huge span. But certainly the preponderance of data is well down, even below heat not burn. So that's a reassuring feature of the unfiltered data. If we look a bit more closely, I've classified the data that I was able to put in my database in terms of which generation, first to fourth. And there is a sense that, this time cancer potency is on the y-axis. There's a sense that the newer generations certainly are the ones that get up towards the potency of tobacco smoke. And these are the ones with all the gizmos, and you can control the power and, as a result, get higher outputs of things like formaldehyde. Okay, nice bit of work by Farsalinos' team, which I've cribbed, and they had 26 users who sat in a room, all vaped the same device with the same liquid, and he started them off, I beg your pardon, at low volts here, low power, and gradually cranked it up to higher and higher power, hotter and hotter outputs, and asked them at the end what was the experience like. And at the low voltage, they all said, oh, it's fine, we'll keep going. And when they got it here, a few of them dropped out and said it was really, they couldn't stand it any longer, so they dropped out. And by the time we got up here, they all dropped out. So I've converted this into, using volts would be pretty hopeless because different devices, different volts would mean different things. But if we turn it into a value of formaldehyde, we might be able to then generalize it. And so the value of 0.3 micrograms per microliter, I've stuck back into my data set, and I've put them in red. And as you can see, they all fall to the top end. So we can, if this is true and generalizable, we can chop out that top end pretty much. In fact, quite a bit of even these, the blue ones up here that are not above this threshold probably fall above this threshold of the summer version. Now, it's not as simple as that. There may be flavorings that can mask this effect and so on. We don't really know, and we really need to replicate these experiments, but it is really interesting that it works out that we chop off the top end. Okay, I need to come to an end. There are many shortcomings. I'm well aware of them all limitations. Things are going to improve. We're soon going to have better toxicological models. I am a bit worried about the metals. Nobody's really studying them. They're very rarely reported. There are things like chromium. The coils are generally made of some alloy of chromium, and yet chromium-6, the most oxidized form, is extremely hazardous. Yet we don't know which form. Is it metallic chromium, chromium-3, chromium-6? We need to know. It's a big question. Also, particle size distributions. You know, toxicologically, it could be very important to know what fraction exists as nanoparticles and are absorbed more rapidly, perhaps. So there are still major unknowns. This is in the e-cigarette domain. But I'm going to finish with, in the first day or so, the continuum of risk became a major theme, and I thought last night I'll make a quick change to my presentation, which they kindly let me change. I'll reorganize all my data in terms of the continuum of risk, and sure enough, we end up with combustion, as everybody says, heated tobacco, heated liquids down to fresh air, and it looks superficially like, you know, in a kid's playground. There you are at the top of the slide. And you slide down, an exhilarating experience, and you end up in terra firma, breathing fresh air. Wonderful. And this is a serious misconception. We really should be thinking, part of it's my fault doing this, because I've put this on a log axis, because we scientists do that sort of thing. You know, Joe Public doesn't. You don't walk around thinking in terms of logs, logarithms, you know, if you think of numbers at all. This is a huge step. That's tenfold. And again, there are big steps down here. And if I put this on an arithmetic axis, you'd have your 100% up here, and then the heated tobacco would be down here somewhere. And then everything else over here would be in this black line at the bottom. So it portrays it wrongly, I think. So I thought, well, steps. So I went on the web and I found this metaphor, if you like, for the continuum. very precarious set of steps that people like me would be really pretty scared of going down, especially when you've got knackered knees. And, you know, so what do? You look at this and you see, where's the bloody handrail? There's no handrail there, you know, so I'm not going to make it down safely. So, you know, pushing the metaphor probably a bit too far. We really need to be thinking of the handrails there for these big steps. So if you're going to go through this, and this is a risk, of course, but in terms of personal experience, it's a grim experience going through this. So you need the assistance, the quit lines and, the advice and so on to get you through all this. And in my country, they're closing all this down, a lot of them anyway. So I think handrails, yeah, we need to think, if we're going to think of the continuum, it's in steps, and we need handrails at the big discontinuities. Okay, thank you.